Hello there. I found this interesting question in the back of my uh, differential equations book, so just want to go over it. So it's find the function whose square plus the square of its derivative is 1. So, dissecting the word salad, you kind of get a function whose square, y squared, plus the square of its derivative, y prime, equals 1. Okay. We can try y prime squared equals, if we subtract that, 1 minus y squared is what I'm thinking. And then if you take the square root on both sides, we're gonna get y prime equals 1 minus y squared. And if we say that y prime is dy over dx, we're gonna get this, and separating separable equation, we're gonna get 1 over square root 1 minus y squared dy equals dx. Okay, so here are the steps so far. If you take the integral on both sides here, this looks very familiar to me. Maybe you might recognize it, but in case you don't, let me remind you the derivative of sine inverse of x is actually equal to 1 over square root 1 minus y squared. Pretty cool. Pretty cool. Something that you forget if you don't do it for a while. Anyways, this is gonna be sine inverse of y equals x plus c. And then I guess if you wanted to, oh whoops, sorry, something bugged out there. I guess if you wanted to get it as a function, you can take the, sine of both sides. Of course, there's some heavy like domain restrictions at this point, but sine of x plus c is going to be your y. And if you think about it, a function whose square plus the square of its derivative is 1, sine fits perfectly into this equation because what we get is, well, so we have y squared plus y prime squared equals 1. You probably see where I'm going with this. We have sine of, let's just say sine of x. Let's drop the c. Let's say c is equal to 0. And let me make this all gray because it's kind of like a note. It's not really part of the solution, it's just like verifying. We have sine squared plus its derivative squared. So the derivative of sine is going to be cosine squared equals 1. And would you look at that? That's your good old friend, good old Pythagorean identity. So yeah, pretty cool solution. Thank you for watching.